There we go. Right. After a NoSQL talk, NoSQL is a lie. So I work for a rather large company. Here's a legal disclaimer that says I can talk shite and I don't have to care about what your opinions are afterwards. So who am I? I am Mike Elsmore. I'm developer advocate. There's the details. So I work here at IBM Cloud Data Services, and I work with or around all this gumph every day. So databases and analytics packages, all we do is we operationalize open source databases and release them into the wild. That one's CouchDB. Actually, that's not a database, but technically I work with that. So there. Right, my day, like most of yours, usually starts like this. Around lunchtime, ends up a bit like this. And if I don't end up like this by the end of the day, something's gone wrong. I'm going to start off by admitting I am not an expert in what I'm going to talk about. I just tinker with all this stuff. I just happen to be tinkering a lot with it. Claiming to be an expert would be a bad decision because there will be plenty of people in this room who know more and will tell me off. So, with a mildly controversial title comes a small rant. So, this actually does get me a little angry. Really, really quite angry. So, we have no SQL. And then we have this horrible, horrible theory that it's just a catch-all. So if it's SQL, SQL. If not, it's no SQL. That's really, really stupid. There's also that horrible not SQL backronym. Just because somebody invented this wonderful term that went viral on the internet like Web 2.0 and Mongo is web scalable, doesn't actually mean diddly squit. This came in after the technologies for bad people who wanted to use terms to describe it. Even worse, you have SQL on NoSQL. So who here has heard of CQL on Cassandra? Sparkle, which has been around for flipping decades as part of projects like Jenna. And Couchbase is proprietary, but it's NoSQL, and they released an actual SQL interpreter for it. So SQL on NoSQL. I think that's a lie. There's also this wonderful thing. NoSQL databases are schemaless. They'll accept anything you put in there in whatever format it takes, so BSON, JSON, etc. That's a complete lie because as a developer, you put a schema on there because what you put in, you need to know what you're getting out. If you put everything in there that you have no idea, why are you using a database? You're not going to know what to look for. It's true. Now, this one's the one that really, really, really gets my goat. There are no such things as NoSQL experts. There is over 5 primary database types. There is all sorts of ones that cross over. So you do have key value and document stores, and they're all mixed pieces of technology that work together. But there are no experts. So if you do claim to be an expert, please follow the GIF. Oh man.
Is that an expert GIF?
That's epic fail.
You can see all the experts on screen.
That would work. And now, oh, damn it. And now I've just clicked reload and it's not. There we go. That's what it should have said. Right. So you can be expert. You can be an expert in the technology of your choice, but you can't be an expert in all of them. It's like me saying, I'm an expert Node, Ruby, Java, Python, PHP, C, C++. Yeah, all of them. You're not going to be an expert in all of them. You're going to be an expert in a subset of these things. So that's the end of my rant. Time to cool down. Calmer. Ooh, sigh. Right, so going to drop some science on this stuff so it makes a bit more sense. Who's here heard of CAP Theorem? Yay! Means I don't have to explain everything, just some of things. Right, CAP Theorem stands for Consistency, Availability, and Partition Tolerance. It's kind of where the CAP bits come from. It's otherwise known as Bowker's Law if you're curious about the inventor's name who actually got slapped onto it. Consistency stands for what you put in is what you get out. So if you put a value of 1 in, you get a value of 1 out, 2 in, 2 out, etc., etc. It's kind of self-explanatory. Availability. Well, that's kind of self-explanatory of it as well. If you put stuff in there, it's going to be available to pull back out afterwards. And then there's partition tolerance. This actually means it survives network failure, so the system continues to work when part of the cluster goes away. I prefer to think of it as the system actually knows where it's saved your bloody data. So that's where the graph is. Just to make a point, that bit in the middle is theoretically impossible. There are new data types under a thing called NewSQL, which is the spanner paper from Google, which are getting around this by using some ridiculous maths, but there's nothing in production yet that can do it. So this bit still is invisible, and I would point at the middle bit over there, but laser pointer to, oh no, laser point somewhere in the middle over there. Doesn't exist. So essentially you've got trade-offs. You can only pick two if you're going to be working in a distributed system, which if you're going to be building any form of modern system, you're going to probably be building it distributed anyway. So I prefer to think of this as sort of like the uncertainty principle. You can know where it's going or how fast it is, but not both at the same time. I think that's the layman's explanation of Heisenberg's uncertainty principle. Can't remember off the top of my head. I'm waiting for somebody to tell me I'm wrong. Oh yeah, FYI, there's an open heckle policy. Go on. Wow, nobody decided to dive on that. I'm surprised. Thank you. I'm okay with that. Okay, that took it too far, but right. So there we go. And why is this important? Well, there's a little bit of history about this. Who has been developing for more than 5 years? Right, so some of these things are going to sound very familiar to you, and we're all going to sit there and groan for a few moments. Consistency and availability, so you didn't even need to consider partition tolerance. Well, you skip that by, you put something on a big box, it stayed on the big box. When you run out of space, you put it on a bigger box and hope the bigger box didn't fill up quickly, and eventually you just had to go buy a bigger box and hope that that carried on working. It's kind of like how most MySQL, MariaDB, Postgres, anything produced pre-2005 kind of worked. Thank God for commodity hardware and learning, yes, distributed systems can be done in a relatively fast network system. So that changed with the introduction of commodity hardware. I forgot I'd put that slide in already. Right, so with the introduction of distributed systems and databases on low network latency, allows you to carry on and not have to consider that. But that still means you then need to know what machine your information is on. Yeah, that's a little awkward when you don't. So you can be partition tolerant and consistent or available. I even counted that as the correct number of dashes for consistent or available. So if you're going to be building a system, you either have to build it in a CP or an AB system. Most databases have gone for the AP system because if your database suddenly disappears, then your entire app is a load of junk, usually. There are some other ones where things like Couchbase went for a consistency model, so they kept as much stuff in memory as possible, which works perfectly for their use cases. So design decisions, I've just gone over that slide again. Really should check ahead for my slides, or load up my slide speaker notes again, which I'm not going to. So why most of them are like that? So you need to be partition tolerant. You know you're in a distributed system, you need to know where it's going. So you can either be available for your clients or consistent for the information they're pulling out. One or the other, not both. So types, primary ones, key value, document, column or columnar or wide column, depending on which definition you're looking at the time, but roughly they're in the same family. Graph. Oh, yeah. There's another one on there called multi-model, and that's the one I'm trying to avoid because it kind of defeats the object of talking about types when you're talking about stuff that's a Swiss Army knife database. It's like people, nowadays, Postgres can do everything, essentially, if you tune it and build it correctly, but you shouldn't, probably, depending on your use case. Like everybody who says, Mongo can do everything, you're wrong. So there are other types, as just said. So object, tabular, all those different ones. I should really start checking my slides ahead, damn it. So first up, key value stores. Anyone name any of these things? Redis, good one. Any older ones? No. DynamoDB, that's technically, no. Dynamo's technically document store and key value, depending on your use case. There's also good old-fashioned Memcached. Yes, that classifies as a key value store. I didn't realize that until relatively recently, but that still actually classifies. LevelDB, no, that's a document database just written in Node. So yeah, and I forgot Riak down there, the one by the Basho company with the lovely sumo head logo. I love that logo. So use cases, usually just pub/sub stuff, so sessions. I did recently start experimenting with using Redis for queues instead of Rabbit. That's actually quite useful. Just means I can be really, really lazy and I only have to stand up one Docker instance on my machine rather than two to do the same job. And considering I'm on a bloody MacBook Air, kind of memory intensive is good. Right, so what does a key value store? It's kind of in the name. It's a key and it's a value. You look at something that's a key and it gives you the value. That's kind of how it works. There are some more complex algorithms that they use. There are 3 primary search types on top of Redis. I think it's 3, 2 or 3. So you can just index, but it's still essentially, it's like a hash, a dictionary, or anything else. It's a key, it's a value. It's quite simple. Why use them? Sessions, queuing. Anyone else got any relatively good use cases so that I can try and remember them for later? And the tumbleweed continues. So, document databases. Can anyone name any of these? Nobody's going to bite that bullet after I was saying no to people in the room. CouchDB. Dynamo, yes. Mongo, Rethink. So, Cloudant, they pay me to be here, so I have to include them somewhere in my slide deck. It's kind of how it works. CouchDB, which is what Cloudant is based off. Mongo and Rethink. I forgot the DB on the end. I'm sorry. Sorry. You know, massive grammatical mistake. Sorry. So, what is a document database used for? Most use cases are as your standard operational data store, so just being able to keep large metadata-based documents in there. You know, user data, product data, all that gumph. So why you would use them? Operational data store, where you put your users and your other data and all that gumph. I should really remember to check my slides before I do this thing. Column databases. Anyone name any of those? Cassandra, Oracle does count nowadays for some reason, but yeah. It's not technically a NoSQL columnar, but it is a columnar. Columnar. I will be able to say that word one day. So yeah, so Cassandra, HBase, and Accumulo. I haven't actually played with that one. Has anyone played with Accumulo? Damn it, I want to find some actual reasons to use it. I can't think of a bloody reason because I've got Cassandra. But right, so what is it? Why column formats? Essentially, you do look at it and use it as if it is an SQL table. The difference is you can just expand the fields in there dynamically. It's pretty much how most of them, the basic theory of using a columnar database. Columnar. Jesus, columnar database is. Why would you use it? A lot of use cases for things like Cassandra is time series information because they have the vector timestamp stuff to be able to series stuff. Useful SQL stuff, so being able to migrate from a MariaDB to Cassandra because then you can use SQL on top of it, things like that. Or just a workhorse database like you'd use any other operational database. Ta-da! Or if you're doing massively distributed stuff because the gossip chat between all of them is amazing, even though it does go haywire every so often if you don't have a sysadmin who knows what they're doing. It's kind of nuts. So, graph databases. This is my personal favorite thing at the moment because they do ridiculously weird things in really, really complex ways, and it's fun. And when they break, you have no idea what's going on. Can anyone name any graph data systems? Orient, yeah.
Orango.
What?
Orango.
Orango. Pardon? Titan technically is a database engine, to be precise. You require to then use something like Tinkerpop on top to apply a full stack system onto it. There's also things like Berkeley DB and other weird ass ones. FlockDB. There's also Giraffe and all sorts of gumph. I like that word, gumph. So, there we go, TitanDB. I've listed it there because oddly enough, Tinkerpop is too large to include Tinkerpop with TitanDB as the underlying data engine. So, Titan, Neo4j, and Giraffe. Anyone here actually been using Neo4j? I'd like to pick your brains at the end. Thanks for volunteering. So, why would you use this stuff? Well, what is a graph data store? A graph data store means storing stuff as nodes and edges rather than as records or documents. Essentially, you can have ridiculously large interconnected data sources which are easily traversable traditionally from an in-memory system. I.e., you take a giant index of it, you reduce it down, then you traverse all over the place, which is kind of really cool, but occasionally means you have no idea what's going on, and you can ridiculously simply create cyclical path errors, which then break everything. which is where it gets fun, because then you try debugging it and reading the stack and you have no idea what's going on because you've got some bits in Node, some bits in Clojure and some bits in Java, and you don't know how they all plug together. That's if you're me anyway. So why would you use these things? Ridiculously complex things. So social networks, which actually aren't that complex, they're just really popular right now. Woo, social networks. Recommendation engines, fraud detection, anything which requires ridiculously complex SQL queries which you'd normally be merging back onto each other in join tables which then fill up memory and make your entire cluster fall over. Breathe. So yeah, that's why you would use them. And after I'm a little exhausted after saying all that, and that may have been a lot of information, but it's cool because I'm almost finished. I've had one beer and I think that may have been too much. Columnar. Right, so what have we learned in my ridiculously rushed through version of this because I'm mildly panicked? No SQL is a lie. Who would agree with me with that statement? Really, nobody? Yeah.
You guys stick together.
Right.
I'll stand.
I'll take that. So, we know why this stuff grew up as the way it did. We also realize that these damn things are different tools for different jobs. If you're throwing Mongo at every problem, you're probably doing it wrong. If you're throwing Postgres at every problem, you're doing it wrong. Rethink, you're doing it wrong. Couch, you're doing it wrong. Everything, you're doing it wrong. The whole point of things like microservice architecture is you pick the right language, the right tool, and the right system to do the job. It is the same with your databases. So if you're trying to do large query types, then you should probably think about using Graph or a large SQL service. If you're trying to do quick operational lookups, Mongo, Rethink, Couch, Cassandra, all this stuff underneath. So pick the right tool for the job rather than just go, my toolbox is Node and Postgres. Done. So picking the right tool means you'll go in the right direction, otherwise you're just going to be spinning and doing nothing. But if you do it right, things look kind of good. And I'm not clicking on, oh. May have accidentally deleted the last slide. I forgot about that before. Damn it. The last slide should have said, questions. No, seriously, that's questions.
No, so how do you, if you've got a project, where do you start saying, well, this sort of data, or what are good rules of thumb maybe at the start, or where to look for good rules of thumb?
That's a good and also awkward question. Because you can't know everything unless you've tried it, of course. But there is an easy way of thinking about it. Are you going to be running large batch process jobs? Don't probably want to be doing that on an operational data store. You're probably wanting to run that on a data warehouse instead. So a BI-based system, you separate them out. That way you can then easily run something like Hadoop, or you can run something quite simply like a secondary service. Braintree, if I remember correctly, run 2 Postgreses. What they do is they have Kafka in the front that keeps piping all the writes in. One of them is treated as a giant BI system, and the other one is treated as a live operational store, so you can still do all the transactions without locking it whilst you do a full table scan. But it's the same as picking that with all the individual technology. You should probably look at the crib sheets. Yes, most of it's full of marketing gumph because we all know what these websites are like. Yes, we can do everything. No, you can't. It's probably a bit like that. So if you know you're going to be using large data, then you probably don't want to think about having to like denormalize that to the point where you have massive fat 10 meg docs which represent a single user. You probably do want to be using an SQL system. However, if you're doing something like a mobile game, you probably are going to be using really small documents, really small packages. So throwing this something at CouchDB where you can naturally just sync between the devices is probably a more sensible approach. So it's a case of, as with everything, research and play.
Sure.
And break it.
Brilliant. Thanks.
That was a really open and really stupid answer, I'm sorry.
IBM probably has a lot of money for supporting lots of databases with lots of sysadmins and DBAs.
Yeah.
But if you're looking for coverage of being able to do different kinds of things, are there 2 main types that you might consider combining as opposed to having to support all 4 major types?
Whoa, there we go. Really that, really. There we go. Ah, Jesus Christ.
Don't have that many DBAs.
Right, quite simply, there's always the option of debassing it. Ta-da, always tell debass. IaaS, PaaS, SaaS, debaz. Database as a service. All this crap is what we sell to you wholesale. But yes, but there are still certain, key skill sets that translate across all of them. For example, the moment you've been working in distributed system with something like CouchDB, you're pretty good at maintaining gossip protocols and intercommunication between nodes, at which point that would easily translate over to something like Cassandra. You just change the tool chain which you're using. But if you want to pick a couple of them which are your primary go-to tools, you'd want one operational one, which is traditionally a document store, preferably something with more than one index type on there. So you'd be looking at, say, Cassandra or CouchDB or even Mongo and Rethink. Essentially, Rethink, just as an FYI for history point, is they decided Mongo was good, but they wanted to rewrite the engine. So technically, the changes feed is a delta feed from Mongo, but renamed for whatever reason. So you want something like that, where it's got multiple query types, so you can adjust it to whatever you're doing in your application, so key value / more complex queries, obviously. And you'd probably want something that's lightning fast, so you're probably thinking something along the lines of Redis to act as an intermediary cache, or to do simple querying at lightning speed. Done. I'm waiting for somebody else to come up with a really arsehole-ish hard question for me to try and answer.
Go on, let's
What's your favourite?
What's my favourite? Oh! No, this one. That one right there.
IBM Graph, why?
Because it's based on Tinkerpot 3 stack, and I've been working like a bastard to build the Node API on top of that. So it's like, I'm playing with really complex things, but I'm doing it in a really stupid language like JavaScript.
Now you definitely are.
Yeah, right.
Pardon?
Have you seen Kaylee? Which
No.
is Google's graph database built on top of Postgres.
Yes, I have seen that. I haven't had a chance to play with it yet. The white paper looks really interesting on top of it.
Okay, so huge round of applause, please.